All right, ladies and gentlemen, welcome to the last lesson of Unit 3. This is dealing with the chain rule. This is a very important rule when it comes to finding the derivative of complex problems. So let's go ahead and take a look at an example that we can do. Now, the only way we can do this right now is if we actually FOILed this, and we would say this is 4x squared plus 12x plus 9, and if we took the derivative of that, we would say it's 8x plus 12. But what I want to make a note of is what I can do to factor this. I could say it's actually 4 times 2x plus 3, and I really want to pay attention to the fact that that 2x plus 3 is there, and it was actually in the beginning. And I'll say more about this 4 in a minute. I know I covered that up a little bit. Let's think about that one. If I try to do 2x plus 3 to the third power, I'm going to get g of x equal to 8x to the third plus 3 times 2x to the second times 3 plus 3 times 2x times 3 squared plus 27. If you remember your binomial expansions from Algebra 2 and pre-calculus, I get 8x to the third plus 9 and 4 is 36x squared plus, what do I have here? 9 and 6 is 54x plus 27. And then if I took the derivative of g of x, 24x squared plus 72x plus 54. And let's think about trying to factor that. If I took out, what can I take out of here? I can take 6, 6, and a 6. I think I can do that. So that's, if I take out a 6, I get 4x to the second power plus 12x plus 9. Well, notice that is actually 6 times 2x plus 3 squared. So look here again, I get that 2x plus 3 again that I started with. And look at here. Here's what I want to make a note of. This is 2x plus 3 to the first power. And guess what? That's 1 power less than 2. This is 2x plus 3 to the second power, which is 1 less than a power of 3. And if you look at 6, 6 is actually 3 times 2, and 4 is actually 2 times 2. So it kind of looks like we used the power rule on this big ugly thing. We brought the 3 down to the front, and we reduced it by 1. But then the question is, where did that 2 come from? Where did this 2 come from if I brought the exponent to the front? Well, the derivative of 2x plus 3 is 2, and it's the same case in both of them. And we could go one more farther, but then I wouldn't have any room because that takes quite a bit of room to do x to the fourth, that to the fourth power. But this is kind of the lead up to the chain rule. I don't know where that dot came from. Okay, if f is a differentiable, or is differentiable at some point, some function, and g is differentiable at x, then the composite function f of g of x is differentiable at x given by this. If you have f of g of x, you can take the derivative. So f of g of x derivatives is f prime at g of x times the derivative of g of x. So if I look at this, we said f of x was 2x plus 3 squared. So in this case, the inside function is 2x plus 3, and the outside function is x squared. So I could say g of x is x squared, and h of x is 2x plus 3. And I could say, okay, it's the derivative of the outside function, so it's 2x to the first power, evaluated at the inside function, which is 2x plus 3, times the derivative of the inside function, which was 2, and that's how I got 4 times 2x plus 3. Or, let's think about the other one. I have a function that is equal to 2x plus 3 to the 5th power. The derivative of this function is going to be the derivative of the inside, which is 2, times the derivative of the outside function, which is 5 times something to the 4th power. And that something is the 2x plus 3. And then I would just simplify this to 10 times 2x plus 3. All right, let's take a look at a couple more examples. This is just one of those type of things that you're just going to have to practice over and over again. So if we go back to this one, I can then use the power rule, or actually do the derivative of the inside, which is 2, times the derivative of the outside, which is 3 times the inside squared, and the inside remains. I didn't write one like this, but I'm going to make this one up here. Let's call g of x equal to the square root of 4x squared minus 1. So if I want to find g prime of x, I take the derivative of the inside of the radical, which is 8x, multiplied by the derivative of the square root function, which is 1/2 to the negative 1/2. And whatever that inside function is, this case, it's 4x squared minus 1. So if I simplified everything down, the 8 and the 2 cancel, that leaves a 4. So I get 4x over the square root of 4x squared minus 1. And there we have the derivative of what looks like an ugly function, but actually becomes pretty simple. I have one more example here before I'm going to let you guys loose, and it's going to combine a whole bunch of things together. Not a whole bunch, just a couple things. So this one's quite challenging because it requires not only the chain rule, but also the product rule, because it's a product of two functions that require chain rule. So if this is my first function and my second function, if you like the u and the v notation, remember that the derivative of u times v is equal to u times v prime plus u prime v. So I need the derivative of the first function or the second function, whichever one you want to go for. The derivative of the first function is the derivative of the inside times the derivative of the outside, which is the inside being 2x minus 1, times the second function, 4x minus 7 to the 4th. So that's u prime times v. So this is u prime times v. And then I want to find v prime. V prime is the same kind of thing, so I need to do plus 4, the derivative of the inside, times the derivative of the outside, times the first function itself, which was 2x minus 1 to the third. Now, I'm going to simplify this just a little bit. This is going to equal 6 times 2x minus 1 to the second, 4x minus 7 to the fourth, plus 16, 4x minus 7 to the third, 2x minus 1 to the third as well. So the big thing with the chain rule in combination with the product rule and the quotient rule is that you really have to pay attention to all of the little itty-bitty pieces here. All right, I'm going to let you guys go with that. I know it was a short little lesson here, but this takes practice. I gave us enough practice problems in here, I think, to get us going. You guys have your assignment, and we will take our unit test on Monday, the 3rd of October. That's the idea here, is to take the Unit 3 test on Monday, October 3rd. All right, I'll set you guys loose. I will see you guys tomorrow.